The desert of southeastern Washington is home to the most contaminated area in the United States. Radioactive and chemically hazardous waste generated while producing plutonium for America's nuclear weapons program has left a legacy of environmental damage and a lingering threat to the Columbia River. The Hanford Nuclear Site was home to America's first plutonium production facilities. Production began in 1944 as part of the Manhattan Project, the World War II effort to build an atomic bomb. Plutonium from Hanford was used in the bomb dropped on Nagasaki, Japan, in August of 1945. For the next 45 years, Hanford's primary mission was to produce plutonium for use in nuclear weapons. Following the collapse of the Soviet Union and the end of the Cold War in the late 1980s, plutonium production at Hanford ended in 1988. Site workers are now engaged in the world's largest environmental cleanup project. More than 1,900 waste sites have been identified at Hanford, ranging from small areas of surface contamination to 177 underground storage tanks that hold more than 50 million gallons of highly radioactive and chemically hazardous waste. Hundreds of burial grounds, large areas of contaminated groundwater, and plutonium-contaminated buildings add to the cleanup challenges. Some of Hanford's waste will remain dangerous for thousands of years. It must be kept away from people during that time. The processes used to create plutonium generate enormous volumes of radioactive waste. Beginning in 1945, Hanford workers began to store the most hazardous of these wastes in large underground tanks. This waste presents Hanford's most complex and costly cleanup challenge. Hanford's 177 underground waste storage tanks, which range in size from 55,000 to 1 million gallons, were never intended for long-term storage. The oldest of the tanks are more than 60 years old. At least 67 have leaked more than 1 million gallons of high-level radioactive waste to the ground. Some of this waste has reached the groundwater. At its most basic, the plan for dealing with this tank waste is to remove the waste from the aging tanks and immobilize it to prevent it from spreading further into the environment. The U.S. Department of Energy is working with a private contractor to design and build a huge complex of facilities to immobilize much of the waste through a process called vitrification, which mixes the waste with molten glass. The molten mixture is poured into containers where it will harden. The waste will still be radioactive, but it will no longer be mobile. The portion of the vitrified waste that contains the highest levels of radioactivity will be stored at Hanford, with the intent to eventually ship it to a national high-level disposal site. The remainder of the vitrified waste will be buried at Hanford. Some additional treatment processes may also be used. Unfortunately, a number of technical challenges and other problems will delay completion of the vitrification facilities by about a decade, to around 2019. That delay will result in waste staying in the tanks much longer than planned, increasing the risk of further leaks. Vitrification of high-level radioactive waste is being done elsewhere in the United States and in Europe, but it's never been done before on a scale as large as at Hanford, or with waste as chemically complex as Hanford's. Since Hanford cleanup began in 1989, much of the focus has been on resolving immediate threats. Initially, there was a great deal of concern that chemicals in many of the underground tanks might catch fire or explode. There was also concern about more than 2,000 tons of highly radioactive spent nuclear fuel stored in leak-prone, earthquake-vulnerable basins, just a quarter-mile from the Columbia River. Another Hanford facility had 18 tons of plutonium-bearing materials that were not suitable for long-term storage. These issues have been successfully resolved. The initial tank safety issues have been addressed. The spent nuclear fuel has been repackaged and is now safely stored in a specially designed building several miles from the Columbia River. all the plutonium has been stabilized for long-term storage and packaged for shipment off the Hanford site. In addition, Hanford workers have put many of the old nuclear reactors into safe, long-term storage. They have torn down plutonium-contaminated buildings and dug up and moved millions of tons of contaminated soils from along the Columbia River. While these are significant accomplishments, much more remains to be done. Leaks from the tanks, along with hundreds of billions of gallons of radioactive and hazardous liquid waste that was dumped into the soil at Hanford, have contaminated about 80 square miles of groundwater beneath the site. Some of the contamination is entering the Columbia River. Efforts to keep some contaminated groundwater out of the Columbia River have met with some success, but are not the long-term solution. The final strategy to clean up the groundwater contamination and prevent further impacts to the river has not been determined. Potential solutions are expected to be both technically difficult and expensive. In addition to the challenges associated with constructing and operating the vitrification facilities, there will also be challenges in removing much of the waste from the tanks. The empty or near-empty tanks and waste that has leaked from the tanks will then need to be removed or somehow stabilized in place. Digging up waste from several burial grounds will be particularly difficult because of the high radioactivity of some of the buried waste and the hazards it will pose to workers. Hanford's 5 chemical processing facilities, the largest more than 1,100 feet in length and heavily contaminated, and surrounding burial grounds and waste sites also pose challenges. Cleanup of radioactive and many chemical waste does not eliminate the hazardous elements in the waste. Much of the Hanford cleanup is focused on changing the form the waste is in, from a liquid to a solid, for example, to keep it from spreading, and to isolate the contaminant so it no longer presents a hazard to people or the environment. This involves putting waste into lined disposal trenches or disposing of it in a geologic repository. In certain situations, covering waste sites with caps or other barriers can also isolate the waste. But just how much of that should and will be done at Hanford remains to be decided. Another ongoing issue concerns how much waste from other federal sites should be brought to Hanford for disposal. Hanford is just one of about a dozen major sites around the country, and more than 75 overall that were involved in producing materials for America's nuclear weapons program. Although Hanford has the most extensive contamination and waste problems, other sites have their own unique cleanup challenges. As other nuclear sites across the country are cleaned up and closed, our challenge in the Pacific Northwest will be to keep the spotlight on Hanford. The remaining cleanup at Hanford will take decades and cost tens of billions of dollars. But it's the price that must be paid to protect current and future generations from Hanford's waste.